This is going to be an overview of finding the different attributes of a quadratic function from either the equation or the graph. So a quick overview of the quadratic function. Our parent function is f of x, or y, is equal to x squared. So if we plug in these different x values and change that to a positive 3, negative 3 squared gives us 9. Negative 2 squared gives us 4. Negative 1 squared is 1, 0, 1, 1, 4, and 9. And if we were to graph this, so our vertex is at 0, 0, 1, 1, 2, 4, and 3, 9. And then it's symmetrical, so we have the same points over here, right there. We can draw this guy in. It's rough. So there's what our quadratic function looks like. Now let's take a look at these points. Our vertex is either the very bottom of the quadratic or at the very bottom of the parabola. In the parent function, it's at the bottom, so 0, 0. That is the minimum of the function. It's at the bottom, so it's a minimum. And the value is the y value of the vertex, which is 0. Our domain, that's the set of all x values. We can have x values that are negative, and there's no limit to how far we can come out here. Whatever value I put in, I can square it and come up on the function. Likewise in the positive. So we can go from negative infinity to positive infinity. The range, however, we can't get lower than 0. So our range is 0 is less than or equal to y is less than positive infinity. X-intercept, y-intercept, they both cross at the origin, so 0, 0 is my x-intercept, and 0, 0 is the y-intercept. Axis of symmetry, this is the line that comes down right through the middle. So right through the middle, that's going to be x is equal to 0. This value is always the value of the value of x in your vertex. P-value, now we haven't talked about p yet, we'll get to that on the next page. But p we find with this equation, p equals 1 over 4 times a. And a is how much it's stretched by, or compressed by. This x squared, the a value here is 1. So for the parent function, p is equal to 1 divided by 4 multiplied by 1. And 4 times 1 is just 1, so p is 1/4 for our parent function. The focus, we're just going to write this down, what it means, but focus is a point, and it is always a point inside the arms of your parabola. So that's not necessarily the right spot for it, but it's somewhere above the vertex when it opens up. And the formula for finding this is your vertex value, and we call that hk, with h being the x value of your vertex, k being the y value, and it's k plus p. So in this case, my vertex was 0, 0, so the focus is at 0, 0 plus p, which we just said was 1/4. So this equals 0, 1/4. So it really should have been drawn right here. We'll make that a big blob so it looks like it's there. Directrix is a line, and it's a line that goes on the opposite side of the vertex compared to the focus. So it's going to be down here, and it is the same distance from the vertex as the focus, which is p. So 1/4, I need to come down. So the equation for this is y equals k minus p. K is the y value of your vertex. So in this case, the parent, it's y equals 0 minus 1/4, which is negative 1/4. Okay, that's a lot of information. We're going to start to put it to use on the next page. Our standard form, a couple things we can learn from this. C equals your y-intercept, and A tells you the direction of the opening as well as if there's a stretch or compression. So those are the things we can get from the standard form. From our vertex form, we can get our vertex, which is at HK. We can also get our A value, so again, our reflection, stretch, sorry, I'm writing fast so it's not very legible, and our compression. So all those we can see from the vertex form of the equation. From a graph, we can see the direction of opening, we can see our vertex, and sometimes we can see our x and y intercepts. We can also calculate A, and we're going to learn how to do that in a moment. Okay, so on our second page, and this is strictly a review, A causes the parent function to stretch, compress, or reflect. So it stretches if the absolute value of A is greater than 1. It compresses if the absolute value of A is less than 1. And it reflects if A is less than 0. K causes the parent function to translate vertically. So it can go up if K is bigger than 0. It goes down if K is less than 0. H causes it to move horizontally. So if H is bigger than 0, it goes right. H less than 0, it goes left. And again, remember in our translation equation, there is a negative sign in here. So if H is positive, let's say H is 3, the equation will actually say x minus 3. It has the opposite sign when you look at it in the equation. Okay, let's take a look at our table down here. My vertex on this guy is going to be at +2, +3. The domain is always all real numbers, so -infinity to +infinity. The range is going to be from the y value here, and it either goes up or down from here. A is positive, so we know that it opens upwards. So my range is from 3 up to +infinity. P we get from 1 divided by 4 times A. My A value in this case is 1/4. So P equals 1/4 times 1/4. 4 times 1/4 is 1. 1 divided by 1 is 1. So P is just 1. P is the distance the focus and directrix are from the vertex. Because this guy opens up, I'm going to have to move upwards. So the focus is at 2, 3 plus 1. So that's 2, 4. The directrix is at y equals the 3 minus 1, which is our P value. So y equals 2. So we're just plugging these into our equations. Okay, let's do the second one here. Our vertex here is at -2, 0. And again, I'm getting that because there's no value here for K. The domain is -infinity to +infinity. The range goes from always the y value here, and since 1/8 is positive, it opens up, so it's 0 to +infinity. P is equal to 1/4 times 1/8, which is A. 4 times 1/8 is 4/8. So P equals 1/4 divided by 8. To divide by a fraction, we take the reciprocal, so we turn it over. 8/4 times 1 is still 8/4, and 8/4 reduces to 2. You could also plug that in the calculator. So we need to move 2 up from the focus, up from the 2 up from the vertex to get to the focus. So it's at -2, 0, plus P, which is 2, so negative 2 comma 2. Our directrix is at 0 minus P, which is 2. So y equals negative 2. Okay. I'm going to quickly skip this one and come here. Our vertex on this guy is at the opposite of this, so 3, 4. Domain is always all real numbers, or negative infinity to positive infinity. My range here, we said we always look at the value here, k, so 4, and I need to know if it opens up or down. We have a negative out in front, so that tells me I'm opening downwards. So negative, it looks like this, and this is 4 right here. So it's negative infinity up to 4 for the range. So negative infinity up to a maximum of 4 this time. My p-value, p again is 1 over 4 times a. My a value is simply negative 1. So p is equal to negative 1 over 4. Okay, so my focus, again, I take the vertex 3 comma 4 and I add p, which is negative 1/4. So this gives me 3 comma 4 plus a negative 1/4 is 3 3/4. Directrix is y equals the 4 minus the p, which is negative 1/4. So 4 minus a negative, is the same as adding that. So y equals 4 plus 1/4, or 4 1/4. Last thing we're going to do here, take a look at a graph. So we need to talk about how we find our a value. Everything else we know how to do. My vertex is at positive 2, negative 2. To calculate my a value, on my parent function, if I stepped over 1 from the vertex, I would go up 1. And check the table on the front if you don't remember that. So if you go over 1, normally you would go up 1. In this case, I went over 1. I have to go up 2 before I hit my function. So this value here is 2. I divide that by how far up we went on the parent function, which was 1. So that gives me an a value of 2. So a is 2. P is 1 over 4 multiplied by a, so 1/8. My focus is going to be my vertex plus my p-value. So 2 comma negative 2 plus 1/8. Oops, that's not an 8. So this really is 2 comma negative 1 7/8, because it's right above here. The directrix, we get y is equal to negative 2 minus p, which is 1/8. That is equal to negative 2 1/8. So that line goes right here. Okay, last one. My again a graph. Vertex is at 2, 1. My a value, if I went 1 over, I have to go downwards here. So I have to go down a negative 1. Again, on the parent function, if I stepped over 1, I went up 1. So negative 1 divided by 1 is negative 1. So a is negative 1. P is 1 over 4a. A is negative 1, so this is negative 1/4. My focus is going to be at the vertex 2 comma 1 plus a negative 1/4. So that's really equal to 2. 1 plus a negative 1/4 is 3/4. So it's right about there. My directrix, we find this from y equals, same as this, 1 minus p, which was negative 1/4. So 1 minus a negative 1/4 is the same as 1 plus 1/4. So directrix is found at 1 1/4, which is approximately right there. Again, these are not perfect drawings. The thing to keep in mind is the distance from the vertex to the directrix is p, and the distance from the vertex to the focus is also P. Okay? Good job.